Last time we discussed the general steps to take before starting any analysis. This week we'll continue our analysis based on our case 1. Hi, it's Amber here. Welcome to my channel. This is where I share my experiences and learn together with you, as we dive into creating analysis projects from scratch. To recap, our goal is to answer this question: calculate each store's weekly absence rate for the past 12 weeks and measure the week-over-week change. To do this, I'm going to use CTE functions. You can think of CTE functions as preparing ingredients before cooking a dish. Before moving to the main calculation, I prefer to use CTE functions for pre-calculation, which makes the final analysis much cleaner and easier. Based on our walkthrough from the previous video, here's what we'll do step by step. We'll start our query with CTE function. First, we use date format on the date column. The format codes X and V ensure that we use the ISO standard year and define Monday as the first day of the week. This helps avoid issues around year boundaries. Next, we define the week start date using date sub. We subtract the weekday number from the date using interval weekday so that each week always starts on Monday. Here's how it works. For example, if shift date equals December 27, 2025, which is a Saturday, then query weekday will returns 5. Monday is 0, Tuesday is 1, and so on. So December 27, 2025 minus 5 days gives us December 22, 2025, which is Monday. This logic consistently sets Monday as the first day of every week. Next, we pre-calculate the absence rate so we can focus only on the week-over-week comparison in the main query. We use a case when statement. When actual hours is null, it means the employee did not clock in and there is no record. We count this as one absence. Otherwise, the employee has a clock-in record, so we count it as 0. We then sum these values and divide by the total number of rows, including both null and non-null records. Finally, we multiply by 100 to convert the result into a percentage. In the where function, we limit the data to only the last 12 weeks, counting backward from today. We make sure the shift date does not go beyond today, so much later dates and older than 12 weeks dates are excluded from the analysis. Finally, we group the data. A simple rule to remember is, group by all non-aggregated column. This ensures the absence rate is calculated correctly at the weekly and store level. Next, we move to the main part of the query. Here we select and display all the columns we identified earlier that we want to show in the final output. To calculate changes from one time period to the next, we use lag window function. Lag is a great choice because it returns the value from the previous row. We use partition by to make sure the calculation happens within the correct group. In this case, we partition by store ID because we want to track each store's absence rate independently. Then we apply a similar logic again. By subtracting the previous week's absence rate from the current week's absence rate, we can finally get the week-over-week change. Alright, this is the full query that answers our original question. Calculate each store's weekly absence rate for the past 12 weeks and measure the week-over-week change. And here are the results generated using our mock data. Okay, this is essentially how I'll approach each SQL video, breaking down queries step by step using realistic, business-focused use cases. You'll notice that as we work through more cases, there are often multiple ways to write the queries. However, many of the patterns and logic will be very similar, especially when solving similar types of analytical question. In the next video, we'll start a new case and we'll continue learning together. I hope you find this series helpful. Thanks for watching, and see you in the next video.